Hello, students, and hopefully this will be our last quiz of the semester going through Wash and Disker, or is it the shell method? Now, there are quite a few problems that will say, hey, do the shell method. It's a lot easier. I think it might be too. But again, it's your choice. It's not. Once you get into the later questions, they do give you an option to either do washer and disk, or a shell method. So looking at this first problem, they're rotating around the y-axis. Well, you have to do the shell method on this because if you look at the picture, and again, let me draw a picture here for it already. So if we try to do a washer or disk, we have to take top minus bottom. And since we're rotating this around the y-axis, well, the top is this side, the bottom is this side. Well, we can't take these same equation minus each other. And if you still cannot visualize this cylindrical shells, they're basically just slices this way, and they're just rotating around. Well, you probably still can't visualize it, but they're basically just slices of the outside of a Coke can, not the top and bottom. They're just the shell of it. And it just has layers and layers and layers, and it keeps on going around. So look at this first one, and again, this might be one of the easier problems. Maybe I shouldn't do this one, but I'm going to. When it says it's a shell method and you rotate around the y-axis, that means it's going to be with respect to x. Unlike the washer and disk, when it says rotate around the x-axis, then it will be with respect to x. If it said rotate around the y-axis, then it's going to be with respect to y. Washer and disk is kind of easy to know that way. Since this is dx, I want to take my constraint here. Well, first of all, let's do the 2 pi r. So it's going to be 2 pi r. R is the x value. And the reason why r is the x value, because that will determine the radius of the shell, like how far out it goes on the x-axis. And then I just got to do times by the height of it, and the height is just going to be this function here. So when you look at this, it's going to be 20x minus x squared. Oops, that's a squared. And since it's with respect to x, it's going to be from 0 to 20. Now, I've already typed it in the calculator, and the calculator gives you, and I times it by 2. I just didn't do the pi. It gives you like 26,666.66666, and it keeps on trying to make that into a decimal. And I try to turn it into a fraction. It doesn't work. Just understand that 26,666 and 2/3, you can write that as 2/3 because that's 0.66666. Remember, you can turn this into an improper fraction by multiplying that number and then adding that number. So the grand total you get there is 80,000 over 3 and then pi. Now, I wanted to go into question number 4, just kind of wrap this up. Again, this is just kind of a little bit of help. I want to kind of make sure you understand. And I try to set up some calculator images so we can kind of look at those. So when you look at this, I'm going to scroll this up a little bit more actually. So when you look at this, basically the region looks something like this. Let me draw it there. Y equals x is just a straight line. That's not too surprising. Y equals, wow, that's supposed to go through the origin. I missed a little bit. The 1 over 23. I can't even write it. It's too small, but that's the equation I'm trying to write out there, 1 over 23. It kind of looks like a square root. It's a kind of like a third root type graph here because it goes down into this quadrant. But what they're trying to get us to find is this region right here. Now we are rotating this around the x-axis. All right, so on the left-hand side, I did do, let me see, this one I did with the shell method, and this one over here I did with the washer method. So let me go ahead and set this up, and I'll try to split it up so it's perfectly displayed here. So the shell method goes 2 pi. Now, I have to go from 0, well, since it's rotating around the x-axis, that means this is going to be dy. So I have to go from y value to y value. Well, what's nice about this point up here, the coordinate is 1, 1. So it's going to be from 0 to 1. 2 pi r, r is the radius, and the height of it is just going to be top minus bottom. So since I'm rotating it this way, actually my shells are going to look like they're going in this direction. So top minus bottom is going to be the red line minus the blue line. So in this case, y minus y to the 23rd power. You type it into the calculator. I times it by 2 because the 2 there, and convert it into a fraction, and it works perfectly. It works great. Now, when you do the washer method, though, it's going to be pi r squared, so 0 to 1, dx. So notice that this one's with dx because it's rotating around the x-axis. I have to take top minus bottom, so just the blue line minus the red line. So in that case, it's going to be x to the 1 over 23 minus x. Just don't forget to square both of them. Now, just notice with my up here, what happens is that I get this. I did try to convert that into a fraction. The calculator goes like error, I can't do that. So I kind of pushed the limit a little bit and said, all right, let's just say if we did 0.586666, I just did a bunch of sixes and converted that into a fraction, and then there's the answer. Just don't forget that I have to include the pi on both of them. This one, I just went ahead and times it by 2, and then I go ahead and add the pi. This one, I just have to go ahead and add the pi in there. I can actually do this with a shell method or a washer disk method. So not possible, not possible. The volumes are different. Then the volumes are, how can the volumes be different? That's ridiculous. The volumes are the same using both of them. That's going to be my solution there. So I'm going to write that as 44 over 75. Don't forget the pi. Put the pi on top. All right. I'm only going to do those 2 problems, but I'm hoping that helps with a little bit of a direction with the washer disk and shell method. This is actually some of the topics that you will start if you begin calculus 2. It starts with these notations. All right, have a good day.